This one? Okay. First this one, yeah. Good, thank you. I'm Marc Portier. I work at the VLIS, Flemish Marine Institute. This is my first, so I don't have the, hey, I'm glad I see you all again. For many of you, it's the first time I see you. And I often have this feeling like I'm the odd duckling in the bucket. I have a history, I'm only at VLIS for 4 years. So I have a history as a software and systems engineer, even in industry, so marine, right? Anyway, this morning, I received an introduction, you all got it, from somebody who actually connected me to you lot, right? Because he was saying, as oceanographers, we are all concerned with the sustainability or safeguarding the viability of our oceans, right? Where I'm coming from, my ocean is the digital ocean, the web. And I'm really keen on safeguarding that we all are using the web the way it's designed for. So I hope that brings us into connection and gives you a little bit of insight in my head and allows you to go along. Because even if I'm going to drop a number of technical terms or acronyms or jargon, don't be blocked off by it because they all have a relation to your actual work. And allow me to explain that. Today's first talk, because that's the other good news, I'm here between you and the coffee break. I have 2 consecutive slots, so you're not done with me yet. But this first talk has been, of course, collaborative work with a lot of people, and I'm sure each of those will, not personally, but their organizations and their projects will get mentioned as I go along. The core thing I want to make clear in this first session is about using semantic web technology, right? For those that haven't been doing it yet, it's a great thing, and there's quite a number of reasons behind it. I hope to make them clear. But there's also a challenge there, because it stems from this idea that we need to do this because the web is so great. And the web has been great, right? You browse the web, and you have the experience of reading one single book. And the promise from the semantic web is that we would now have a database system managed by everybody and nobody, just like the web, that by now would have brought us to a level where we would query this database as one single database. And that didn't happen, not yet. Why didn't it happen? Well, a lot of people will tell you it didn't happen because the technology stack is too damn difficult. And I'm here to argue that that is not a problem, right? So bear with me. Why are we considering this, right? A lot of people are looking at maps, data maps, right? So what you're doing at that moment is you're actually having 2 different data sets, doing 2 different measurements, but you overlay them based on some geotemporally axis. You put them together, and then you see either coincidences or contradictions or whatever, and that gets your research going, right? And the whole idea about applying semantic web is actually what I would call introducing more coincidence points. So not only geotemporal, but actually create a whole knowledge graph that is connecting from your measurement to all possible things that are related to it. And again, that might seem very conceptual and weird, but as a real scientist, each time you are delivering your data to a system that doesn't allow you to also connect it to all these axes, you should be worried. You should be talking to your management, you should be talking to your data management, you should be talking to your IT department, because something is wrong there. There is something in your head you know, and you can't attach it to the data. It means it will get lost, right? So this is what it is all about. And in the end, imagine that indeed, right, we would have introduced all these connected elements to your data. You would actually have something not only like a geographical map, but you could have a conceptual map, for instance, of the funding in Europe, or of all the project infrastructure, and see how that coincidences and correlates to how data measurements are being connected to that, right? So imagine that kind of world, right? Where you can find the hey, that's funny observation that is typically driving research, right? Good, now my core statement. RDF, and that's, I think it's the only acronym in my slide, That's the real technical thing that enables the semantic web. And people typically, and read this statement, because I'm so glad I found this somewhere hidden in a foreword of a book. I'm going to read it out loud. People think RDF is a pain because it's complicated. The truth is even worse. RDF is painfully simplistic, trust me. It's also when an engineer says trust me, then when it goes wrong. But RDF is painfully simplistic, but it allows you to work with real-world data and problems that are horribly complicated. And the bottom line is, while you can avoid RDF, it is harder to avoid complicated data and complicated computer systems. And that's actually where RDF will help us. While making sure that the data coverage, how we bring it, we don't have to consider it anymore. That's covered. Use RDF and then spend time in the complicated stuff, right? So this is an awesome quote. Anyway, if it goes to my main message of today is RDF, why did we make it so complex? Well, there are a number of myths around it, right? A lot of people are not getting into publishing RDF because they're making it themselves too complicated. And I have to say, a little bit of criticism here, the good examples of doing RDF in the marine world have been kind of templating the hard way to do it. Because you don't need a Sparkle endpoint to be publishing RDF, right? While that has been a lot of common cases in the marine science, you don't need that. You can do it a lot simpler. You can actually publish RDF as simple as you are publishing HTML. And the misconception is for a lot of people, a Sparkle endpoint is the same as a SQL database, but it's not. It's not a backend system, it's a client system. It's a system to question to ask questions to an aggregated or even a federated cloud of data, which is not what a SQL database is doing, right? So don't consider Sparkle first, consider publishing first. The second thing is when you do the publication, a lot of people waste a lot of time in very big ontologies. You don't need to do that. Take the example of BRDC, SCOS, go SCOS, simple, straightforward. SCOS actually stands for Simple Knowledge Organization. So the simple is in there. Keep it simple and stupid. Get your message out. Use not ontologies, but even just vocabularies that are out there, and make sure it's understandable. And all that other stuff, and all those quotes out there from very important and smart people, I can go on about them for ages. The most important one, nobody is interested in the types. People are only interested in the values. Types are important, but to programmers, right? To people building systems and validating the systems, not to the people actually using it. So focus on the values and how to get there, and that will be a lot easier. So there is an alternative road to linked open data, which I would call low-cost linked open data publishing. Go for producing RDF. You can even embed it in your HTML, right? You do have to pay attention to trustworthy and sustainable URIs, but that's a good thing anyway, right? It's having persistent links everywhere in your website. And reuse many of the vocabularies that were mentioned today already, right? You have, I'm not the first one to mention schema.org, Dublin Core. Maybe I'm the first one to mention Void and Descartes. ROR, ORCID, all those exist, but especially in the marine domain, you have the Ocean Info Hub today. You have, since ages, the NERC vocabularies. We are introducing, I have a small slide on that, a little new venture in the Margraph project, but all the CDataNet Sparkle endpoints providing Edmos, EDIOS, etc., they're there to be used, right? And then on top of that, there's some technical stuff. Please consider fair signposting and what Salva mentioned, considering LDS feeds, which is actually an RSS for your data, really something you should consider. Margraph is really about, Salva showed marine regions. We're going to do the same for worms, and eventually also Aerobis, which is on the data point level, making sure we have linked data publication of biodiversity measurements connected together. Please visit Ocean Info Hub. Jan Bart mentioned oceaninfohub.org. Somebody else mentioned the handbook. But there is also a dashboard, and there is a Sparkle endpoint, really great for investigating. We are working on a number of smaller things, which I'm glad to expand upon, but not a lot of time for that. And I think my last slide is my invitation to receive any questions on this. Because then I'd like to go on to the second part, which is about federated queries. That's the really interesting stuff. So, any questions?
Thank you. Justin Buck. Just forming the question. So, RDF is simple. It represents complex problems.
Yes.
Are you aware of a simple generic tool that can go on top of those complex problems to enable people to interact with it without needing to know Sparkle or the detail of situations?
I'm glad you're asking. I can come back to my previous slide. I didn't have time to introduce our last bullet there. We're actually working on that. We call it the Knowledge Graph Analysis Platform. It's dubbed the K-Gap. What we've come to realize is that the big thing is people think in graphs. Actually, this is how we think. We think in this is the dat of the dat of the dat. So we think in a linked associative way. But when we're dealing with data, we're not dealing with graphs. We're mainly dealing with tables. So data providing is structured data. It's tables. It's CSV. So what we created is a simple tool to convert CSV into graphs. We did consider CSV for CSVW, and we did consider RMLAO, but we did in the end create something ourselves, because I think what we created is a lot more down to earth for actual people to use, and it's just a templating language. So like a lot of people are going to use HTML templating, Giorgia, to produce HTML out of CSV. We are doing the same to produce turtle files out of, so that brings it down to the level of people that are knowledgeable with tables and can produce a template. And on the other side, we're doing the same with the analysis or the reporting side, because we've also seen that the data scientists, they have trouble interacting with this graph, right? And Sparkle is a very weird thing. So what we're providing for them is a tool we call Knowledge Graph to Table, which is in fact a way to template your Sparkle query. So you only need one person in the team that knows about the Sparkle, or even you can share these templates among each others. I actually have that together with Alex. I created a number of those templates on top of the NERC vocabulary. And I think you have the NSV Sparkle GitHub thing. I can share it. It now has a subdirectory templated queries, and that's using that tool where you just say, I have the name of this query, I provide these parameters, and out comes, this is the result of a Sparkle query, is actually a table again. And so all the data science are happy. You export it as a data frame, and off you go. You produce reports, you produce all that kind of thing. So yes, there is work to do to leverage and make sure people that are not knowledgeable to graph thinking get to use this stuff. But it's not that hard. So there's a number of low-hanging fruits we can get there. Right? And I'm very keen on starting using the Ocean Info Hub and add some more templates on top of that. Yeah. Good question. Thank you, Just.
Hi, thanks for this presentation. RDF is quite, well, that's available for a couple of ages now.
Yes.
DCAT and schema.org and so on. Do you feel that there are any disruptions or trends that are changing the way we should look at the metadata and the ontologies? Well, I'm particularly thinking about the LLMs, but maybe there are some others.
Very good question, deep question. Slightly vicious in the sense that it kind of refers to why haven't we been seeing more success, right? And I take that. Actually, my next deck is trying to address that. And I think there is in my next deck also more on those trends and future developments. But yes, one of the things I mentioned, really at the bottom of this page here, is linked data fragments and Communica. This is work done at the University of Ghent by computer science department. And they're really coming down to the understanding that what I was hinting at, that Sparkle is not a database backend system, but it's a way to query your system. So what they created, Communica, is actually an in-browser Sparkle engine. I would not call it a Sparkle endpoint, I would call it a Sparkle start point. It's what you interact with as an end user. And the thing that is doing is actually using traversal. It can go and fetch, as it finds triples, it go and fetch for more triples while it's executing its query. It's quite mind-blowing, but I think there's a lot of good to come from them. Yeah, I think there's definitely trends. Other trends are the kind of work Alex was showing. People are discovering gaps, right? Because your analysis on the semantic work is like, here, we can't close the gap, right? The same goes with our own tool, KGAP. We start using this, and we identified that while I did mention ROR.org doesn't have linked open data publication. It's a pain. Somebody should provide it, and it's really not that hard. Actually, I hope to find an intern to do it this summer, right? So there's a growing attention to it, yeah. But I would really, I think the main message is, let's keep it simple at first. Because we need a bigger base of data available that is well connected to start showcasing. And that's one, I think, of the key message. Jan Bart didn't mention it, but one of the founding ideas behind the Ocean Info Hub was this idea where they say, let's focus on the plumbing, not on the fountains, right? We need this interconnected data set first, and that's boring work, right? But it's not hard, it's easy. It's as easy as publishing automated HTML pages, right? And so you even should use static website generators, all that kind of stuff. I'm not eating time, it's the questions.
We need to go to the next presenter, which is you. Yeah. And you will have less time because you took your time.